Assalamualaikum and selamat sejahtera. In this video, we will discuss the operation of three-phase, controlled, half-wave and full-wave rectifiers. These rectifiers have the same operating principle as the three-phase uncontrolled rectifiers except the drive requirement. Like other control converters, the three-phase control rectifiers need a control signal for their operation. As similar to the single-phase control rectifiers, the control signal for the three-phase control rectifiers is supplied from a single source at a specific firing angle. The effects of the firing angle can be seen in the conduction ranges of the power switches and the wave shape of voltage and current waveforms. In this discussion, we focus on the control rectifiers constructed using thyristors only. Let's start with the principal operation of a half-wave rectifier with resistive load. As shown in the box, the thyristor with the highest potential of the anode terminal will start the current conduction. However, the operation of the thyristor is initiated by a control signal injected at every commutation line. At this moment, the firing angle is equal to 0. Hence, the current location of the first control pulse is 30 degrees. To understand the effects of the firing angle, we will change the value of the firing angle within two ranges. The first range is referring to the range between the first commutation line until the blue voltage waveform is equal to 0. According to the graph, the range is equal to 30 degrees. Therefore, the first range of the firing angle is in between 0 to 30 degrees. If we consider the new firing angle is 15 degrees, thus the conduction ranges and control pulses will shift to the right by 15 degrees too. As a result, the new location of the first control pulse is 45 degrees. The second range of the firing angle is in between 30 to 120 degrees. The 120 degrees is measured from the first and second commutation lines. If the new firing angle is 60 degrees, hence the control pulses will shift to the right by 60 degrees. As a result, the conduction ranges are also shifted and the new position of the first control pulse is 90 degrees. Next, I will show a simulation work to study the effects of two ranges of firing angle toward the wave shape of voltage and current waveforms of the three-phase controlled rectifiers. For the first range, I will apply alpha equal to 15 degrees, and for the second range, alpha is equal to 60 degrees. Other than these two firing angles, I will also show you what will happen when alpha is equal to 30 degrees and 120 degrees. In this simulation, I will measure the three-phase voltage waveforms together with the control pulses, the line currents waveforms, red, yellow, and blue, And lastly, the output voltage and current waveforms. In this simulation, I will start with alpha equal to 15 degrees. I will zoom the steady state waveform only. Next, let's compare these simulation results to the voltage and current waveforms of the rectifier when alpha equals to 0.